I would like to take this moment to look a little deeper at the code within logistic regression, because it's important that you understand the essence of what the code does. It's not critical that you understand all the mathematical nuances. That's not the point here. The point is that you understand the code enough to get a sense of it, so you feel comfortable with it. So it's not just like a foreign language to you. It's like a language that you're learning and that you could communicate with to others. So I'm going to pose questions and answer them for each of these lines of code. I'll go up here where they're labeled. Okay, so import, well, it kind of tells us above, but let's say the question is this: what does this line of code do? Okay, someone asks you. In fact, I would like you all to put it in the chat right now. Put in the chat what this line of code does. Okay. And yes, you may put import model, which I have above. You could try to be a little more specific, okay? So here's a conceivable answer. And there's not a right answer so much. There are answers that make good sense and some more sense than others. Like what it doesn't do is build the model, okay? What it does do, it imports the logistic regression machine learning algorithm. That's what it does. So it imports it from the sklearn.linear model library so that we can use it to build a unique model. Okay? So we're importing the algorithm here. Okay? That's a powerful step, because what this means is we are not writing logistic regression from scratch. We are actually using the logistic regression algorithm that sklearn provides. I showed you in the slides some of the key points, mathematical points of how that algorithm works. But we don't have to do that. Okay? We're not hard coding that, right? We're taking the algorithm, right? And we're using the algorithm. And when we import logistic regression from sklearn.linear model, that allows us to use the algorithm. Okay? sklearn, that is it's short for scikit-learn. That is where like it lives, okay? Look, I've got some extra things up here. I did double check on my saving CSV file. Go ahead and type in sklearn logistic regression, okay? When you do that, the first return should be the scikit-learn official documentation. This is the official documentation. This is the official model. This is where everything exists. Do I expect you all to be able to understand this? No. Okay? My point here is simply that sklearn is the library where this lives. And this is all the info. And later, some of you may be able to navigate some of this. And you can say, hey, there are these default parameters. And what can I change? But we're not focused on that now. Up here, you could click on scikit-learn. And look, it has its own page, of course, right? And look at the top. Classification, regression. It's what we're talking about. Algorithms, okay? These are machine learning algorithms. Algorithms and models are sometimes used interchangeably. I can tell you that I like to think of the algorithm as what is there in the library. It's what's been built. It's what's been created for us to use. And the model is what you create uniquely to your data, okay? And in particular, this is defined as a kind of linear model, which is interesting because it's actually a curve. But this is not, high school algebra anymore. Linear often does include curves, okay? It's because it's one-dimensional, all right? And it also has, it's continuous, okay? It's interesting, Anyway, that's how they group it, right? Okay, so that's the first line of code. It's a big one, right? That's the thing about these lines of code. They're big, okay? They do a lot. Okay, up next. Put it in the chat. What does this one do? And I know half of you probably put initialize model, which is true. That's what I wrote. But can you be a little more specific? You could say initialize logistic regression model. Okay, you could say something more. You could say we define a variable here called model, which is it's which is the logistic regression algorithm before it's been fit to any data. Okay? So when we do that model right there, it's go back to the scikit-learn page. Oh, the scikit-learn logistic regression page. Let's type it in. The forward is not an option. Yeah, it's somehow like it's better. It works better in Google. Oh, there it is. It actually is at the top. You get that when you initialize it. You have this, okay? You don't believe me? Check. Let's check. How do we check stuff? Where? This one. We'll print it in right here. See that? Look at that. Look at this. You have the model in this line of code. It just hasn't been fit to any data yet. Look at all this stuff there. That's virtually identical to what's here, maybe in a different order. Penalty L2, C equals 1.0. Come back. C equals 1.0. Penalty equals L2, okay? L2, by the way, standard penalty. All right, so again, what this line of code is doing, it is establishing logistic regression as the machine learning algorithm that the variable model is defined as. It is ready to rock. All it needs is data. Okay. All right. So you could go into a lot of depth with these lines of code. So what about here? What is this? Well, I like to say this is where the magic happens. This is where the machine learning model is built. Okay, what it does, it takes the algorithm, right, all these defaults, and it fits it to the data. It goes through all those iterations, okay, all those rounds of, what's the error? Oh, it's high. Let's try it again. Let's use gradient descent. Let's go closer, move closer to zero. We want the error as closer to zero as possible. Let's go through 1,000 iterations. Let's just keep trying and keep fitting. We're mapping everything to 0 and 1. We're using the sigmoid curve. If it's greater than 0.5, it goes to 1. If it's less, it goes to 0. Didn't do well. Let's keep going, keep trying, keep adjusting, all the way until it's done. That builds the model. That builds a unique model to your data. Okay, model.fit. It fits this algorithm that you have imported from the sklearn library to the specific data, and in particular the X and Y that you have defined. Okay? I'm getting pumped here, right? And what is this? What is this last line? Well, we're scoring the model, right? And again, let's be more specific. Put it in the chat. Scoring it how? Well, what it's doing, it's going to generate the model. See, when it fits the model, right, if it can always get 100%, I mean, great, but it usually can't. So it's did the best that it can. So now when we score, we see how well did it do. We compare the actual results to the model's predictions. And the scoring metric here is accuracy. Okay. We'll talk about scoring metrics another time. And what that does, it's simply percentage correct. So we got, it's down here, 79.8% of the predictions were correct. Okay? All right. So I'll leave up what we did here, right? It's kind of fun to print things and like look at them, and dig a little deeper. Okay, so that's a little bit of a deeper dive as to what these lines of code are. And again, do you need to understand these in great depth? Not necessarily, but I want you to understand them enough so that when you run, like down here, right? We run these 4 lines of code, you're not just like, oh, I don't know, but I know what this means. Just be like, well, you have an idea of what it means. Like we're importing a model that's designed for classification, and then we're fitting that model to the data where X, okay, is we didn't talk about X and Y much. X is the predictor columns, okay, This is what the model is training on. This is the input, right? X is the input, right? It's a function, okay? Functions need inputs. All these columns are the inputs. Let me go to the data. Here it is. Okay, so let's just take the first row. Okay, so X, here's one row, okay? By the way, you could consider dropping this unnamed 0. In fact, I want to do that and see if it changes. Because what is that? I mean, it's just like an index. And you would think that that shouldn't matter, right? It shouldn't make a difference, like where somebody, like if you were the first person or the 370th person, like what your income's going to be. But when you give it, the model's going to try to look. And it may find something that's not there, it may find something that's there. Let's delete it and see if it makes a difference. But first, as is, you're going through all these columns, okay? And, you know, it's finding a weight for each individual column. So it's going to do a random choice, right? Now, the ones that are zeros, whatever you pick is not going to matter here, but it's going to matter when they're 1, right? So this is a big undertaking. It's a huge undertaking. Can you imagine trying to pick, what do we have, 90-something columns, and you're trying to pick all the weights to get this one right. But in all those like cases, right? What was it like? We did the shapes. 30,000, right? You've got to try to get 30,000 correct, okay? So your X is everything but the last column here, right? These are all the inputs, all what you're trying to predict. The idea here, by the way, is that you are going to gain something from each column. You're going to gain something by associating income with country. You're going to gain something because you know, right, their educational year and their capital gain, which is a big one, the number of hours they work per week, right? And so the machine learning algorithm is going to try to find those gains to map them to Y. Okay, it is no longer one DF. It is an X, which is all the info that you have, all the data coming in, and the Y, which is what you're trying to predict. All right, so there's a deeper dive. As promised, let's try this. I want to try it. Delete DF, and then, what was it? See, it's blocking, I can't see it. Unnamed 0. Now, if it doesn't, like I'm just going to copy this. Sometimes if you click away and click back, it doesn't give you the options. Because it's if you copy it, you should get it exactly correct. Like it looks like there's a space there, for instance. And that's hard to tell. You know what? I'm going to reverse the head. Put it right here. And got rid of it. Okay. Now I've got to run these all again. Well, this one again, because now I've got a new DF. And then we can jump down here and see, will we get better than 0.798? Or will it be the same? Or will it be worse, right? It was a little worse, right? So, and this is interesting because it doesn't necessarily mean that this model is better, okay? It got about the same percentage correct, but slightly worse. I mean, the one before was better. Because again, that's the thing about, well, which one's going to do better on new data? It could be picking up on something that's not there. And that's not surprising that when you eliminate an X column, the score goes down. But I think that's usually not the case. Okay, so understand also what X and Y are here. That's my point. And if you can understand all these things, you are in fabulous shape going forward. Job well done. You're building machine learning models. It's just going to get more exciting from here.